Okay, here we are. I'm struggling with my technology, to tell you the truth. I was going to do this in the classroom, that didn't work out, and then I recorded a lecture that had no audio. So I hope this is recording. Let me check on something. It looks like I have some audio. So anyway, I'm sorry about that, and I'm sorry your schedule's messed up. I hope that is not too problematic for you. We don't have class on Monday, and then we'll get back together on Wednesday, a week from today, for the test. So anyway, I'm just going to start midstream here. Let's see, laptop and profile. All right, so this is this is what I wrote about an hour ago, but I'll just step you through it. This is a little bit of a review. We started out with this, but we're now into chapter 6 through 8. That is the next section of the class, and that's on statistical inference. The first 3 chapters were on, setting up the theory for this, setting up for theory, the theory. You remember there's 2 branches of statistics, the descriptive and inferential. Now we're on to the inferential, and I'm glad you made it here because this is what the universities are going to expect you to know, and I'll try to help you learn that. So let's remind ourselves, statistical inference is drawing conclusions from sample data, and then that comes along with a level of confidence. Okay, so it's not enough just to state your predictions, but you have to tell in some way how confident you are in those predictions. And the two most common are confidence intervals, all right, where you take a sample and you use the statistic to estimate the population parameter. That's kind of intuitive. That's kind of what you might think when you think of doing statistics, right? And the second kind is hypothesis testing, where you give evidence for a claim. Okay, where you give evidence for a claim. So if you need to make these in your notes, like you can stop the video and write those down, because I just kind of whipped through that. What do I mean by a claim? It's like I come up with an idea, like a guess or a hypothesis about something. Like maybe I would say, I'm guessing, or I hypothesize that 10% of Gateway students drive car. Am I like in the video here? 10% of Gateway students are in a car. Then I'll go out and get some sample data to either give evidence in support of that or not. Okay, that's what hypothesis testing is. Chapter 6 is confidence intervals, and chapters 7 and 8 are hypothesis testing. And both of these are based on the sampling distribution. That's why we spent so much time in chapter 5 talking about that, because statistics is based on the sampling distribution, okay? Not necessarily on the distribution of the population, but on the distribution of the statistic, the sampling statistic. So anyway, that was a quick run through of an intro to this section, and let's go ahead and get started with confidence intervals. All right. I hope you make it through this. You can watch it on fast speed, maybe. That would help you. All right, do I need to read this or write it down? I'll read it, and then we'll decide. It says the probability that the population mean, let's say this is confidence intervals. All right, so we are going to take a sample statistic, and we are going to estimate the population parameter, right? Now, the probability that that these two are equal is 0. Like the likelihood that I get the exact number in my statistic as the population is, for all practical purposes, and actually mathematically it's 0. So it's better for me to kind of state an interval of possible values than the exact values. And that comes along with the level of confidence. Let me see what this actually says. It's virtually 0. Instead, you can estimate that the mean lies on an interval with a certain level of confidence, right? You make an estimation, an estimation that the population mean lies in an interval with a certain level of confidence. Okay, so you can't just say, okay, here's my sample, and I calculate the statistic, and that's the population mean. You can't do that. Instead, you use the statistic to come up with an interval. You say, I'm estimating that the population mean is within that interval with a certain level of confidence. Okay, that's what we're doing. All right. So I have here, I don't want to I can hardly read my notes. I don't think it would help you if I put it under there. But there's two parts, all right? There's the estimation, and then there's a level of confidence. So 1, 2, make sure that you realize that there's two parts of a confidence interval there, okay? Now, here's some terms. We're going to talk about some statistical terms now, and this is a little bit, boring, because it's just like, okay, here's the term and here's the definition, but you know, before you can have a conversation, you need to know the words, what the words mean. So here we go. And the first one is sampling error. All right, sampling error. And so let's say this is the true value, right? The population parameter, that's the true value. And then for whatever reason, I end up here with my statistics value is actually below the mean in this example. And this distance here is the sampling error. In other words, every time I take a sample, I know that I'm going to have some error. And it could be large or small. Maybe I got the particular sample I got had a lot of high values in it, and so it was way up here. Or, you know, maybe it was close. But regardless, there's going to be an error. And that, just for terminology, that's called sampling error because you don't have all the data. Can't get all the data. So do I know what the sampling error is? Well, if I know what this value is. If I knew what that value was to get this distance, I wouldn't have to do this to begin with. So I don't really actually know the magnitude of the sampling error. Okay. What else do I need to know? So the idea, here's what happens. So you don't know where this is. You actually don't know where that is. But you do know where this is. Right? This is your point. And what you do is you say, okay, I'm going to put an interval around that. And then I'm going to say, I'm estimating that the mean is in here somewhere. The true mean is in here somewhere with a certain level of confidence. Okay, there's the interval. And I know this point, and from this point I come up with a boundary with a certain level of confidence where, in theory, I have captured the mean. Okay, and that's the confidence interval. I hope this is recording. Let's see here. It looks like it is to me. All right. So, okay. So let's talk about the confidence level. I have next bar here. Let's say here's a number line. And let's say my interval is that big. and it has a certain level of confidence. If I make my interval bigger, let's even exaggerate. If I make my interval bigger, is the confidence level going to go up that I've captured the mean? Or is it going to decrease? If I make the distance from here bigger, is it more likely that I've captured the mean as opposed to this confidence interval? And the answer is obviously yes. Like I'm going to mean my basket is bigger. Like my net of catching the mean is bigger the wider my confidence interval is. Right? Because I just have more possible values. So why don't I just, keep making that interval as big as possible, and then I would be certain that I got the mean. Well, if you do that, you've kind of weakened the value of your estimate. Kind of like if I said, I'm guessing that the population test average for Gateway is between 10 and 99. Like, what is that telling me? That's not telling me anything, right? Like, of course it is. I'm 100% confident that the test is between 10 and 99. Well, of course. Didn't have to do any work to know that. In other words, but if I make the interval smaller, I might say, well, I'm 90% confident that the test scores are between 75 and 80. Well, that tells me something. That's a reasonable estimate. Okay, so anyway, just to kind of clarify the relationship there. By the way, the confidence level is C, and it's typically expressed as a decimal. Like this is the 90. I'm 90% confident. All right, that's C. All right, let's keep going. All right, so another thing is, another terminology is called the margin of error. Right, so here's my estimate there, and then this is my confidence interval. This distance here is called the margin of error, and it's just E. Okay? And it's the maximum distance that I could be with a certain level of confidence from the true value. Like, in other words, the farthest away the true value could be is this distance here, either on that side or that side. And that's called the margin of error. And just for right now, I'm just going to give you the equation for that. Remember, we're talking about the sampling distribution, so it's ZC times the standard deviation of the sampling distribution, which is, if you remember, is for the mean, is that. So in the homework problems, they might say find the margin of error, and they give you, they'll give you this, or they'll give you the ZC, sigma, and square root of n, and you just have to calculate that. That's the formula you're going to have to use, and I'll show you where we get that in a minute. All right, I think that's good. Yeah, I'm going to skip all that. All right, so here's the heart of it. Let's see how this goes. This is kind of the exciting part to me. It's the exciting part. Now, let's just imagine that I'm going to get a sample of, let's say, the weights of everyone that goes to Gateway. And I get a good sample, a good representative sample, and I calculate the mean. And, the mean is, let's say, 189.6 pounds, right? Just for example. Now, how do I know if that's accurate or not? Like, I have one data point. In other words, I just have one data point. Just out there. It's just a data point out there. Now, if I knew the distribution of the sampling distribution, think about that. If I knew how the distribution of all the samples I could possibly have taken, then that would tell me something. I'm going to make this up. Let's just say my sampling distribution looks like this. All right. Well, right off the bat, if I knew this before I took the sample, I would say, well, it's more likely that I get a sample that's in this part of the distribution than out here. These aren't very likely. These samples can happen, but they're not very likely. Most likely I'll get that, right? Again, I only have one data point to think about. So what do I know now? Let's talk about the sampling distribution, and we're going to talk about the sampling distribution for sample means. What do I know? Well, the first thing I know is that if my n is greater than or equal to 30, that the distribution is going to be normal. So that tells me something. This is from the central limit theorem, right? It's normal. Which, okay, that tells me a lot. Like my sample's going to have this distribution, and now which one am I going to get? I don't know. But at least it's going to have that kind of a distribution where these samples are more likely than these. The other thing it tells me is that the center, this is the sampling distribution, the center, this distribution is going to be centered on the true value. All right, this center is actually going to be centered. That's a good thing. I mean, it's not shifted down here. So I know where that's fixed. It's fixed on the true value here. And that's from the central limit theorem. And the last thing I know is that the standard deviation of that is equal to the standard deviation divided by the square root of the sample size. Okay? All right. So this is good. Let's just look at this distribution. This is the distribution that's just out in the wild. It's out there. It's, we aren't going to take all those samples. We're going to take one, but if we took them all, it would look like that. And let's just put some numbers on. Well, let's make some little divisions here. 1, 2, 3. And these are standard deviations, right? Each one of these. All right. So what's the likelihood that the sample that I take is going to be within 2 standard deviations of the true value? What's the likelihood? Well, I know it's normal, right? And because of the empirical rule, I know that I have a 95% chance that my sample's going to be within 2 standard deviations of the mean, right? 95% likelihood that I'll be within two standard deviations of the true value. Okay. So this is all I got, right? I just got one data point, but I know it's likely that I'm within 2 standard deviations of the true value. That tells me what exactly does that tell me, because I only have this data point out here. Or I just have a data point. Well, here's the interesting part. Since I know that my sample is 95% likely to be within 2 standard deviations of the true value, that's the same thing as saying the true value is within 2 standard deviations of my sample. technical difficulties here. All right, if I'm saying that whatever sample I get, it's 95% likely that it's going to be within 2 standard deviations of the true value. You can see that. That's the same thing as saying the true value is within 2 standard deviations of my sample. Like, let's say I'm sitting here in my office next to the wall here. Here's the wall. And this is me over here, sitting here, trying to explain this to you. And I'm saying, look, I'm going to be within 2 feet of the wall. I guarantee 95% likely that I am 2 feet from the wall. That's the same thing as saying 95% likely that the wall is 2 feet from me. All right? That's the trick. That's the trick. So here I am. I take my sample. I calculate the statistic, the sample mean, and then I put these intervals on it, all right, that are 2 standard deviations from the sample value, and this is my confidence interval, and I can say that with 95% confidence that the true mean falls within that interval. Does that make sense? That's the beauty of it, right? That's the beauty of it. And the only reason I can say that is because I know certain things. I know that the sampling distribution is centered on the true value, and I know that the distribution is normal from the central limit theorem if I make my n greater than or equal to 30. And because that I have this graph, and I can make, within a certain level of confidence, a prediction about how far away my sample is likely to be from the true mean, from the population parameter. One last thing here. Let's see if I can. So, like I said before, if I make the confidence interval bigger, if I make this interval bigger, then my confidence goes up. So let's start with the confidence, and let's say 95% confidence. That corresponds to what? 2 standard deviations, right? 2 standard. This 2 is what's known as ZC. This C and that C, they're related. If I make this bigger, right, then I'm going to make my confidence interval bigger, right? And if you remember, 99.7 was 3. Typically, they don't use the 99.7. They just use 99, and that comes out to be, what's that number? It's 2.575. All right? So if I want to make my confidence 99%, then that corresponds to 2.575 standard deviations from the mean. Like 99.7 is actually 3, you know that. The 95 is 2. That's kind of an approximation for 1.96. All right, so 2 standard deviations, I get 95% confident. Actually, it's 1.96 standard deviations. All right, and then 2.575 standard deviations, right? That's even farther out, gives me a 99% confidence interval. The other one that's common, and I didn't put these in order, but that's okay. A lot of times you get a 90% confidence interval, and that one is 1.645. All right, so this ZC tells you the number of standard deviations you have to go. All right, and this is the corresponding confidence interval with it. And what exactly is that? If you look, this is a Z distribution. If I put, all right, if I get 95% of the data, 0.95, this would be like in your StatCrunch between, and you have 95% of the data, then this would be 1.96 here, or 2, 1.96, and this would be a minus 1.96. The ZC is only the positive one, but it really means both of those. All right, so the area under here that gives you the confidence level corresponds to how many standard deviations you are from the true value there. Okay, I hope that made sense. That's the whole theory behind it. Let's see what else I got. Yeah. Let me just finish up with this. So we said the error term is equal to ZC. This is the number of standard deviations times uh, sigma over square root of n. Okay. So let's just say I have my x bar here, and my error term, margin of error is here. And in this example, I'm going to use a 95% confidence interval, right? What does that mean again? It means that my true value is going to fall within 2 standard deviations. And I keep using 2 just because you're familiar with that, but it means it's 2 standard deviations from the mean. All right, so my E, this is my E term. And it goes in both directions, that distance here. Now, how do I know that distance? Well, let's just say my standard deviation is, I don't know, let's just say my standard deviation is equal to 3.5, right? 3.5 pounds, right? So what's this distance here? All right, this distance is going to be the ZC, all right, I need 2 standard deviations to get to 95. All right, so that's going to be 2 times times the number of standard, that's the number of standard deviations times what that standard deviation actually is. And since we're talking about the sampling distribution, then this is going to be 3.5 divided by the square root of n. And I can't remember what I said, but let's just say, I don't know, I had 50 people in my sample. Right? In other words, to get this error term, you need to know the number of standard deviations, which are going to be like, what's that number, 1.645. These are going to be that for 1 standard deviation, 90% confidence interval, or it's going to be 1.96 for 95%, or it's going to be 2.575. Right, so that Z term is going to be one of these 3. And then this one I have to get from my data. Right, and I'm just going to take the population standard deviation divided by the sample size, square root of the sample size. So anyway, that's kind of it. I think I had a... I'm just going to stick this up there. Forgive me for that, but this is in your homework. This is problem number... it's in your homework. It's one of the last ones here. And it says, from a random sample of 49 business days, the mean closing price of a certain stock was this. All right, so this is a sample mean, right? That's the sample mean. And this is a random sample of n is equal to 49, okay? Assume the population standard deviation equals 11.55. So these are the numbers that you're going to get. And then it says build a confidence interval. Let's say a 90% confidence interval, right? 90% confidence interval. Here's my data that I'm given. And then here's the equation. Well, the 90% confidence interval corresponds to 1.645 ZC. That's how many standard deviations from the mean. And then I'm going to plug in, like, well, what's the value of the standard deviation? It's going to be sigma, let's see, this thing here is sigma all over square root of n, right? So I plug in those numbers, and I get E to be that, all right? So E, so this is 127.49, 0.89, and then I'm going to add E there to get this data point, and I'm going to subtract E to get that one, all right? So here's my E, it comes out to be that. And I'm going to take that, subtract the E, and then this is the mean, again, the mean plus plus the E, the error term, and so this is going to be my confidence interval there. All right, so I don't know if that, I hope that wasn't too confusing. This is where you're going to get the interval. You take your sample mean and you add and subtract your margin of error. And your margin of error you're going to find with that equation. So I hope that did it for you. I hope this recorded. I'd hate to go through that again, but that's the heart of like the confidence interval right there. If you understand that, you're going to have no problem with chapter 6. We're going to change the statistic. Remember, we're working with sample means. The one question that you might ask yourself is, well, how do we know the standard deviation of the population? They just say assume. And to get the standard deviation, that's the deviation from the mean, and we don't know what the mean is. That's what we're trying to estimate. Well, that's a great question. The reason that we have this section is so you understand the theory, and we're making some assumptions, and I'll clear that up in the next section. So anyway, I hope this helped you out. I will see you next week.